Hi, I'm Kane Dixon, and I'll be presenting my senior project, which is the production line design for an automotive company. This presentation will cover an introduction of the problem statement and objectives of this project. It will cover the design and features of the designs with different layout alternatives as well as station improvements. It will cover the methodology of comparing the different alternatives and the capacity analysis. It will cover the results of the study and then a conclusion. The problem statement is that the client company needs to meet demand for a product and they currently do not have enough capacity. The objectives of this project are to develop an optimal layout and design for the new production line, determine what measures will most economically increase the throughput to meet their demand, and for this throughput increase to meet their demand for their product for the next 3 years. The first design is a station improvement. This is a machine idle light in order to address wasted time on an automated machine. This wasted time results from the manual conveyance of the machine, where the workers are already working on other parts and do not notice that the machine needs to be fed. This machine idle light will indicate the workers that the machine needs to be fed and will reduce this wasted time. The next design is a layout. This is alternative 1, featuring an Ursa machine that is signified here. This will be expensive to move, and this layout does not move this machine. It also has the second line feeding into the first, merging for the final assembly and test stations, as well as the final inventory. This causes the line to only have 3 in and out flow points. The next design also keeps the wave solder machine in place, and this alternative replicates the final assembly and test stations and creates an extra inventory point, thus having 4 flow points in and out of the line. Alternative 3 has the wave solder machine moved and creates a U-shaped line. This also replicates the final assembly and test stations and has an extra inventory point, also creating 4 in and out flow points for the line. To evaluate the relative benefits of the different alternatives, 3 criteria were considered. These are flow efficiency, relative cost, and reliability. For flow efficiency, the amount of in and out points was considered, where the alternative 1 is the strongest in that it only has 3 flow points, whereas alternatives 2 and 3 each have 4. For relative cost, alternative 1 is again the strongest alternative, in that the cost of replicating the final assembly and test stations is eliminated, as well as the cost of moving the wave solder machine, which makes alternative 3 a less attractive alternative than either 1 or 2. In terms of reliability, alternative 1 is the least reliable due to the station merge. However, there is data available from the client company regarding the final assembly and test stations, which shows there is a reliability of 97.5%. Since this is a high reliability, this criteria is weighted very low. For evaluating the station improvement, I performed a time study. This time study concluded that 4 minutes and 46 seconds of value added time for the machine, with an average wasted time of 34 seconds. The machine idle light is projected to reduce this time by 29 seconds for a new non-value added time of 5 seconds. The non-value added time will still be 5 seconds because it takes time for the worker to set down their tools and walk over to the machine. In order to evaluate the capacity of the line, I needed to determine the takt time. I first calculated the labor hours per quarter based on number of shifts, length of shift, and other factors, and I applied efficiency and utilization factors to give a more reasonable estimate. I was given demand for the first year, and I projected it out to 3 years in order to encompass the project's scope. I divided the available labor hours by the demand in order to get the takt time for each quarter. I replicated this process for the final assembly and test stations, since I identified them to be critical stations that need to have a capacity analysis. Using existing cycle time data and the calculated takt time, I evaluated the number of stations that would be needed to keep the cycle time below the takt time. The test stations move from 10 to 20 stations because the client company already put in an extra 10 stations, resulting in the final 20. So I included this in the capacity study. For the final assembly, there is currently one station, which will give a cycle time per station of 2.81 minutes. However, if this were moved up to 2 stations, the cycle time per station would be 1.4 minutes. The results of this capacity analysis gave results for complete lines and the critical stations. The complete lines are summarized to the right with their respective takt times. The critical stations, takt times, and cycle times are summarized in the 2 comparison tables. The current takt time cycle time comparison table shows the final assembly and test times with 2 and 20 stations respectively and compares them to the takt time. As you can see, duplicating the stations does not quite meet the demand. The demand can be met with a 3% efficiency improvement. This only equates the 2 times. With a 5% efficiency improvement, there is a slight buffer between the takt time and the cycle time. The use of 2 shifts instead of the previous 3 shifts for these critical stations will provide savings annually of $109,279 and will still be able to meet the demand. The machine idle light will provide savings of approximately $6,400 per year from labor savings and additional value of parts produced by reducing wasted time. In conclusion, the total projected savings of this project are projected to be $115,679 annually. The machine idle light may be installed and will reduce wasted time. This benefit will be approximately $6,400 savings annually. The final assembly station should be duplicated by year 2. The efficiency of critical station work must improve at least 2% by year 3. This will meet the demand for the 3-year period. And the critical stations should be run with 2 shifts rather than 3. They will still be able to meet demand, and the benefit of this change is projected to be $109,279 savings annually. Thank you.